A lovely afternoon, or chilly here at Project Lamport, but today we're looking at a number of different things. First of all, we're looking at carbon in our soils, and the way we're measuring carbon is to look at it as a ratio to the amount of clay content in the soil. And the way we do it is we take bulk density rings, such as this one I have here, and using a tool like that, we punch these rings into the soil at different depths, and from that we get the kind of mass of soil for a given volume. At the same time, we're taking samples of organic matter, and we obtain the organic matter content at those depths and also the clay content. And with a little bit of mass, we can work out the mass of clay and the mass of carbon within our soils, and then we get a thing called a carbon to clay ratio. And from the work that's been done previously, we know that if we've got a ratio, some say somewhere between 1 part of carbon to 8 parts of clay, we define that as a healthy soil. And the other extreme really is sort of 1 part of carbon to 13 parts of clay. We call that degraded soil. And here at Project Lamport, we've got organic matters of about 4.5% typically, and clay contents of around about 30%. And that comes out as a ratio when you do the mass as about 1 to 13. So even all the things that happen to this soil over many years, we're looking at it as still a kind of degraded soil. The other thing we're doing with this bulk density is we're looking at the sort of biophysical effects of all the worms and roots and all the different benefits from our cover crop systems at depth. And what we're finding over the last couple of years is that the bulk density at depth now in our no-till cover crop plots, so the combination of the two, is now dropping bulk density to the same level as our subsoil plot on its own without cover crops. In other words, the power of roots and biology, those biophysical effects of biology, if you like, are doing the same job as quite intensive, expensive tillage. So the other thing we've been looking at, we've harvested all our sort of biomass samples from our cover crop systems here, and frost has pushed them back as well. But this year we had really big biomasses, double what we had in previous years. But for the first year, we've seen a difference between our tillage plots and our non-tillage plots, and our non-tillage plots have had literally double the biomass than our tillage plots, and that's because of the dry summer and planting them in the dry. We retain the moisture and residue on top of the soil in our non-disturbed plots. So 3 interesting things. We've been looking at carbon and looking at that as a ratio to clay. I'd argue that's the only proper way of looking at carbon. We're looking at the effects of our roots and biology and worms and all the interesting things down there are dropping our bulk density to the same level as our tillage plots. We've only seen that in the last 2 years. And then finally, we've been looking at cover crop biomass. We've had big biomasses, but double in our no-till plots compared to our tillage plots. So that's a little update from Project Lamport, what is on a beautiful afternoon here, and lots of interesting things we're learning each single